documents when you're traveling. So, but the thing was, this paper shredder was made by some 3-letter acronym of the government. I can't remember which one it was. And what they did was actually in the top built a scanner. So as you're shredding your documents, it's scanning the document. It would send it actually over the electrical line using like modem, like pulses of the electricity to another room where it was being reconstructed again. I thought, that is awesome. So the mobile landscape, just talk about some generalities. You guys are all security folks, so you probably know a lot of this. Mobile's hot, right? Who isn't being pressured right now to get a mobile app out today? Right? Marketing teams are pressuring development teams saying, hey, we need our product out now. And a lot of the time, security takes a back seat over getting your product out. So that's a big time challenge. A lot of the times, mobile app developers don't have the type of security expertise or any knowledge really when it comes to mobile app development. And the reason I think that is because it's so easy to make a mobile app, right? Things like Cordova, and so you just drag and drop your app together, ship it, done, man, this thing's awesome, and with no respect to security. And I think that's a little bit harmful that it is so easy to make mobile apps these days. Talking about the numbers of devices, I mean, it's just exploding, right? So, and again, we can see how it's grown over the years. We're at 5 billion devices right now, mobile devices that are out there. So again, increased attack surface. You know, these are all potentially 5 billion devices that could be vulnerable, have any number of apps that are vulnerable to critical issues. We did a case study a while back where we took 120 mobile applications, and we found that 66% of them contained a critical or high vulnerability. And what I mean by that is we were able to disclose users' personal information that was unintended to be disclosed, or we were able to compromise the backend system. So perhaps the mobile app using a RESTful API or SOAPy type thing, and we were able to, say, inject it. You know, they can be vulnerable to the same type of vulnerabilities as any web server will be, and I'll show examples of that in just a bit. So, a lot of the times we think of a mobile app, well, it's just an application, right? Why is it really different than, say, any other application, a thick client or a website? And there's 2 important differences. One is magnified network vulnerability. So, does anyone have an idea what I mean on that? Anyone with a guess?
It has to get a lot more. Probably since your mobile device is more places, it's transmitting more information to more.
Well, more places is the key, right? So when you're in the airport, hey, free Wi-Fi, great, let me hop on that. Or you're in a shopping mall and hop on somebody's shady, Wi-Fi connection. You have no idea what is being pilfered from your device over the network. So as you're, logging into your bank and such over a shady Wi-Fi connection, that could be getting man-in-the-middle attack, right? So they're sniffing your traffic, stealing your logins. So that's an important differentiator. And the other one, magnified physical vulnerability. So a common occurrence is you leave this somewhere. You can lose this. It's kind of hard to lose a desktop. Right? And this is completely embarrassing, but because it's BSides, why not? So I was doing the same talk for a user group for our company, a bunch of people like you all, and I'm doing the same thing and magnifying physical, and I go to reach my phone, and it's not there. What the hell? And I look back, and before the talk, I was sitting at a desk back there, and I see my phone back there. It's like, I meant to do that. See, guys? There's an example of how you can leave a device behind. They didn't buy it either. So looking at the threat surface, when we're analyzed, do we have any QA folks in here? Security QA?
Security, like QA in general.
Just in general, hey, this is fun, and any QA people can test mobile apps, and I'm going to show examples of that again as well. So that's good. Normal pen tester folks? Anyone focused on mobile? One? Great. Couple. So when we analyze a mobile app, we consider 3 areas of attack. We look at the client. Again, that's the device itself. What is happening on the device as I'm using an app? Is it writing my credentials clear text to the device? Is it reaching over the sample? Is it looking into other areas of the device that it shouldn't be? Or storing data where it should not be, into a publicly accessible area of the device? Poor certificate management. So a lot of the times, developers will disable SSL cert pinning. And they do that because it's cheaper and easier to test, right? Because you're in your QA environment. Oh yeah, it's pinned to our production server. Oh, let me just turn that off, the cert pinning, and they forget to re-enable that, and they ship it to the App Store. So now I can man in the middle that application as a bad guy with an application, with the app. We look at the network. So again, this helps a lot when the developer turns off cert pinning, because now we can get in the middle easily. And we're looking for like data leakage, right? If you have Google Analytics or some other analytics package library in your app, what data is the app deciding to send to Google Analytics, right? Is it containing sensitive user information that probably shouldn't be going there? So that's another example of that. Of course, clear text credentials, so not using SSL at all, of course, big problem. And then we look at the server side, and this is probably what most of you are familiar with, server-side attacks. So looking for SQL injection, cross-site scripting, parameter injection, directory traversal, you name it. All of those apply to mobile backends as well. And the thing that makes it hard, why we find so many problems here, is developers think that because it's just an API, it's not a front-end web page, it's just an API backend, that they think, well, no one's going to find that, right? Google's not going to index it. So forget it, right? It's just a backend API. Well, I guarantee you the bad guys are going to find that backend API and find their way into your systems via the mobile API. That's a very easy picking, actually. So again, a lot of times developers like, no one will ever find that. Don't worry about it. But they do. Any questions on that? So now we can get into specific examples. Okay, so again, these are things that we have seen through our testing or things that have been in the press big time. So server-side vulnerabilities, we'll start there. Like I said, they're vulnerable to all the typical web server type vulnerabilities. This one in particular had WebDAV on their backend server and allowed the click command. So basically it became an open server, a file server, because we could put, pull, delete anything we wanted to on the server. And maybe it's like, well, why is that bad? So there's this backend and you can upload a file, no big deal. No one's going to go find that file and download it. Well, what we're going to do though is upload some malware to that site, grab the link, and go do a spam campaign, right? Or a phishing attack. And send out the company's website, right? Because this could be XYZ company, whoever we're testing. So it looks like a legit link. And we actually did this. Click here to win free tickets. And then here's the evil link that takes you to the malware that will get downloaded and installed. So because they didn't test the backend server well and make sure that it was secure and that we couldn't upload just any random file, we're able to now use this in phishing attacks. Kind of a different way to approach it, phishing. And it's cheaper because I don't need my own server to host this stuff. I can use the company server. This one wasn't a developer mistake, but I thought it was interesting when it comes to mobile. So British Airways hack, ever remember this from not too long ago, right? Maybe 6 months ago? When looking into this and the way it was done, they were using a cross-platform toolkit. Okay, so think of maybe Xamarin or Cordova or something like that. So you write the code once, and then you can have your website and your mobile app all in one. And so their payment system was also shared across that. So the mobile app, when you open it, it would go and pull scripts from their server, which is the correct thing to do. And the problem is they were compromised from the inside. And in their payment system, they injected a MageCart skimmer script into it. And actually, there's a talk after this one in the same room on that exact topic if you want to see more. So you may want to check that out. So it's interesting that I bet the hackers didn't really think of that. That they were thinking, okay, we're going to compromise the website, and every ticket you purchase it would process the ticket and then grab all your information, credit card number, social security number, whatever you typed in there, and shove it over to the bad guy's server. The thing, again, that made this neat with the mobile app is it pulled the same script. So now you went from one vulnerable asset to hundreds of thousands. Every single British Airlines app now was a credit card skimmer. And every ticket you bought was being sent to this bad guy's server. So I just thought that one was kind of interesting, how kind of unintentionally the threat surface just went, exploded exponentially. There was a company called Bright City, and this one was in the news, and this one was really frustrating too, because they were made aware of the vulnerability ahead of time, and they completely ignored the researcher. Said, hey guys, you guys are doing some really bad stuff here. So what they were doing is this system was a way that local cities and governments would advertise to their residents and say, hey, put in your... use this app to basically catalog what's in your house. So if your house burns down or it gets robbed, you can say, hey, these are the things that I have in my house, and so I kind of have proof of that. So people used it, and this one particular researcher found that you could basically enumerate any account, the entire database of all accounts. And so they had a call, API, Bright City Apps, get user, and you would put in like a user ID 1. And simple enough, if you put in 2, it didn't validate that it was actually you. It actually gave you the next user. And so just simple account enumeration was on this back end for this mobile app. And then what made it worse is with the response, when you said get user, it returned back username, password, date of birth, email, you name it, the whole thing. So I wasn't just getting account names and such. I was getting their entire account because I had the username and password just by enumerating IDs through it. So that was, and again, that they were made aware of this and they totally blew it off. And then Brian Krebs got involved, I believe, and kind of posted something. And when Brian Krebs says something, everybody sort of jumps. Then it became a big deal, apparently. That's going to be actually one of my next talks is when security researchers go ignored, because I'm seeing that more and more and more, where somebody comes out and we told them about it, but they ignored it, and they disclose it like, oh, yeah, that is, yeah, we're looking at that. So that's going to be my next talk. So looking at the network, so this was an example where we were testing an application for a big-time boy band. So think of like New Kids on the Block. Any New Kids fans? Okay, one, great. Don't be ashamed. So that was so their target demographic for this app was probably girls 10 years old to maybe 16 years old. Very popular band. And so we're testing this app for security vulnerabilities, as we should. And we were man-in-the-middling the traffic. Okay, so common way of testing a mobile app, one thing you want to do is look at this. So you get in the middle. We can use various methods on the device to disable cert pinning and get in the middle and really get a good capture of what's happening. So the tester's testing, he's using the app, everything's going great, and he's watching the proxy log just sort of flip by. And all of a sudden something catches his eye. He's like, wait a minute, what was that? And he sees his home address in there, all the way down to the street number, 123 Deer Street. It was the exact address. And he's like, I never put this into the app. And so this application was harvesting home addresses for every single user without them actually typing it in there. Probably using GPS to grab that data and upload it to their servers. And I just thought, is that a vulnerability? I don't know. That's a horrible decision to be doing that, especially with that target demographic. Certainly kind of frightening. So we flagged that. I don't know if they did anything about it, but that was pretty scary stuff. Latitude and longitude was included in that too, in case they were confused on the address. Yes?
Third-party data leakage, is it through the REST APIs?
I'm sorry, say it again?
The third-party data leakage, is it through the REST APIs?
Through the APIs?
Yeah, the last one, third-party.
Third-party data leakage, is that through an API?
Yes, that's an example. That's not this one, though. This wasn't an API. This was actually the developer of the app was doing that. It wasn't like Google Analytics pulling this data and sending it to their server. This was a conscious decision by the app developer to include this. I think I do have an example, though, of third-party data leakage. So this one, another conscious decision by the developers. This was for a big-time social networking app. I'm not going to say the name, but it was big. And I was playing around at the time, and I was trying to, as you can see, mobile testing is kind of hard, right? There's a lot of aspects to it. And I was like, how can I make this easier for our testers? And so what I did is I thought, well, Android's open source. Why don't I make my own OS based on that? So I downloaded the entire Android code base and started modifying it to capture things I care about. So anytime something is written to the device, I would write out to a log where I could see that happening. Or anytime traffic was sent over the network to the server, just grab that and give it to me. And because I'm inside the OS, I can get to it before encryption. So it took away, so it made it really easy to do man in the middle to test these applications. So I'm testing it, this application, and similar to before, traffic's flying by, little line items, gets. And all of a sudden, I see this hunk of code come out the device and get sent to the server. I'm like, what the heck was that? What did I break? Clearly, there's an error going to be in here or something that I broke something in the OS. And I start looking through it, and I'm seeing things like home screen mode, running services that are on the device, screen brightness, if you have your key guard enabled on the front of the device, your SD card free space. So it was harvesting all this data all about your device and pulling that back to the server. Again, I was like, I had no idea this is happening. And it has nothing to do with this service that I'm using on the back end, right? They're just clearly harvesting this data to resell to other companies, and I just didn't know it, that type of data was being taken. Do you have the front camera? Is the rear camera enabled on your device? I'm thinking, man, that is crazy. So that was just one of those accidental things while I was trying to troubleshoot something else, and this thing rolls by. I'm like, what in the world is going on?
So did you make your OS open source or not?
So it was for a while, but it's been discontinued. I don't think you can get anywhere. If you look up Shadow OS, I did have it out. It wasn't open source, but it was freely downloadable. I probably need to resurrect that. But if you look up Shadow OS on the net, you might find some stuff on there. But I don't think the download's available. But it was downloadable as a emulator image. So you run an emulator, and it came with a little Windows log viewer, basically. And as you use the app on the device in the emulator, it's logging all these, lists. So it made it easy also. If I type in my username and password, I can see immediately, something got written to the device. I can open that file, it would pull it off, and I can say, look, there's my username and password, and it's not encrypted. That's a problem. So eventually I'm going to come back to that and hopefully open source it and make that available. Similarly, Bose headphones, so they got nailed also, kind of similar to the other situations where they're just harvesting information. So now the end thing, right, with these high-tech headphones, you get a mobile app to control, your EQ and such. Well, it was also taking every single song you were listening to and uploading it to their server so they could build profiles on the music that you're listening to and, again, resell that information. It's like, I had no idea it's doing that. So they did, I think, end up getting sued for that as well. Looks like a lawsuit filed in Chicago, so this is maybe 2 years ago. I'm not sure what came of that. Oh, and speaking of lawsuits, I should also mention the British Airways example. That, I believe, is going to be the first example of a GDPR violation. And that could be extremely serious for them, like financially.
It's 4% of revenue, right?
What's that?
It's like 4% of revenue, I've heard.
I'm not sure what the details are. It could be.
It's pretty, it's substantial.
Yeah, I'm thinking that they were first. Google was later with the Android devices, right, with taking information. That was a little more, and they've already been fined, I think, which was like a day worth of revenue for Google or something.
Yeah.
So I'm not sure what came of the British Airways. It was like a month after they passed GDPR, and then that hack occurred. And if it's per user, that was exploited. If you think about it, with a single server, okay, I don't know how many that is, but then you add up every download of British Airways mobile app, and if they consider that as part of the damage done, I mean, who knows how much that could be. So I meant to go back and look and see if anything came of that or what happened there. Starbucks, I remember, this was quite a few years ago, but they were all in the news. They got hammered big time in the news for that, where people were able to steal information, or malicious apps could take your username and password out of the actually third-party API, so this was Crashlytics that they were using. And for whatever reason, the developer thought, hey, whenever you log in to the app, the username and password, I'm just going to write that entire HTML package into the into the session log of Crashlytics, which is accessible by other apps, right? Other apps write to this log. And so they were basically storing clear text usernames and passwords in it. So that's an example where they used a third-party API. It didn't, I don't think it left the device, but they were writing in clear text to an area where malicious apps could gain access to. I thought this was kind of funny. When they, for whatever reason, this news organization went to Crashlytics and asked them, hey, what's up with this? You guys are writing, clear text passwords. What are y'all thinking? And so they had a quote back. When reached Wednesday, Crashlytics, a Boston-based firm that specializes in crash reporting solutions, couldn't comment on specific customers, but did reiterate that the firm doesn't recommend developers log sensitive information. It's like, don't do that. That's not our fault. That's the developer's fault that did that. So that one gained a lot of notoriety. Client-side logging. So a lot of times, many developers, I'm sure, you're doing logd or whatever, or console.write. And a lot of times, developers don't take those out. So, we've seen where username and password, you log in, a developer, to try to be helpful, will log that out so they can see, okay, is it the right username and password for testing purposes, and they don't end up removing that. And so this is a common method we use for testing mobile apps, is we always run with the log viewer running as we're using the app, just to see what the developer decided to spit out into the log. And quite often we will see usernames and passwords or tokens and keys and such being written out. So that's a pretty easy, low-hanging fruit thing to do while you're testing a mobile application. Another one on the client side. So this was several years ago, and this isn't really a problem much anymore, but we had several banks have this problem that they would submit their banking app to us, and we'd test it. And does anyone use that feature where you take a picture of a check and deposit it, right? Well, what we found is that the developers, for whatever reason, when you would take a picture of the check, would write it to the global camera roll that all apps had access to. So right there was every check that they were taking the picture of stored on the device, unencrypted, and had other apps could have access to that information. So, and in this one particular case, they submitted the app. They're like, hey, hurry up. We got to get to this app store. We got to get this out now. So we test it, we find this vulnerability, and we send it back to them. And they say, and so like a day or two later, they say, hey, we fixed the problem. Here's the app. Do a remediation test. Test it again. By the way, we just submitted this to the App Store because we're in a hurry. Like, all right. I mean, that's your call. Do what you want. So we test the app. And we found another issue where they had a feature that you could, through your bank account, you could see pictures of what's been gone through your account, and you could swipe through everything that's been submitted. And as you're swiping, it's writing every one of those back to the global camera roll. We're like, no, stop. Sent it back to them again. So again, it's kind of an example too, where again, your developers are under pressure to get these apps out by everybody, and how security definitely takes a backseat to saying just getting your product out there.
Jobs.
That's right. Good for us, bad for consumers, I guess. And this has been largely done away with because over time, iOS is doing sandboxing by default now. So everything you write, like if you say save image, it goes in your sandbox for your app and nothing can reach into that. So there's been a lot of mitigations based in the OS that kind of take care of that for us now. So it's actually more difficult to get outside of your sandbox and store things, which is a good thing. Client-side debug screens. So a lot of the times apps will, developers will put in a debug screen in the app itself, and if you're an admin, they'll enable it. Okay, so let's say I'm using application XYZ. If it's a banking app, I can log in as an admin, and it will give me an extra menu item that says, debug. And I can go into it, and they have certain things like disable SSL cert pinning or diagnostics. So these are real hidden screens that are already in apps. And hackers have ways of triggering these screens out of the binary. Okay, so like in-memory updating. So when we run an app, we can actually modify the memory space that the app's running in and say, and you'll see is admin equals true or false. Well, let's make that true. Reload the screen on the app, and all of a sudden there's a new admin menu. Okay, so and now I have access to these screens that shouldn't be there. So some of the interesting things here that we found, like in this middle example, upload log file. This had absolutely no control on what was actually being uploaded. So we could go to that back end and turn that into an open file server for us. And we were able to find that because of this debug screen. Let me see, what else did we have? Server. So I could change between production, staging, or canary with this app. Well, that just gave me 3 more targets to go hit. That's awesome. To go find more vulnerabilities. So using these debug screens, we had one, I don't know if it's in here or not, but it included their SSL key in it, like their private cert key in it. And I don't know why they put that in there, but they did. So, but kind of the things you can find in these debug screens. And the thing we kind of recommend is, again, one of those things, again, don't do that, right? So if you're going to go and make your release build, have it do a conditional compile to not include these debug screens. These were all in the App Store. And they just didn't have to be there for that version, right, for the consumer side. But we will, if we find those, we're certainly going to use those to try to find more holes in the apps. Any questions? Flying through.
I do have a question.
Yes.
What's your favorite tool for runtime memory manipulation?
For what?
What is it?
Favorite tool for what?
Oh, for memory manipulation. What is that called? Flex on iOS. So that's a free tool you can download, and it will let you take a look at memory, all of the activities, for instance, or iOS calls them something else. But all the screens that are in the app, memory locations, a lot of different things. So that's a pretty cool tool. If you look up, I thought there was some other part of that name. Is anyone familiar with Flex? If you look up Flex and iOS, it should pop up somewhere on the internet. But it's a pretty neat tool. You'll want to run that on like a jailbroken device and then install the app and take a look at it. So this is our last example. This is one of my favorites. So this app that we tested was so secure, they used voice recognition to log in. So you would set up the application and say, "Hi, my name is Ray," and save that as that's my login. Okay, and so we tested this. "Hi, my name is Ray." Okay, and did everything else, and nothing would get by it. It actually worked. It was great voice recognition. No one else could get through it. Okay, that's cool. So let's move on. Let's really try to break this thing. So one of our techniques is like a before and after screenshot of the application's directory on the device. So before we start testing, we look, okay, here's 20 files in it. There's libraries, there's text files, XML files, what have you. Okay, so there's a snapshot of what that looks like. We'll use the app, exercise it, do things, and take a look afterwards. Oh, look, there's 25 files. So clearly something got written to the device, and that interests me. I want to know what that is. and see if anything's there. So poking through these files, and we find a file that made no sense. It was like zebra.xyz. File extension didn't make any sense, the name, like, whatever. And so we open that up in just a normal text editor, and it looks like complete garbage. Okay, well, this is either encrypted or binary type data. I'm not sure. And I look a little closer, and at the very top of this garbage, I start seeing clear text words like genre, album, year made. Anyone?
MP3 file.
MP3 file. And so we took it, dragged that file over to the PC, renamed it MP3, held the phone up, and ran it. Hi, my name is Ray. Got into the application. So the developers in that case were thinking, security through obfuscation. I'm going to rename this file extension, and no one will ever figure it out. And another terrible technique, but it's more common than you think, the security through obfuscation. So that was kind of one of my favorite ones that we were able to bypass. That is actually the end of the presentation. You can follow me on Twitter. VB is best, so if I had any credibility, it's gone now, probably. That was actually the first versions of WebInspect were written in Visual Basic, all the way through version 6 or 7. So, yeah, follow me on Twitter. I'm open for any questions. Yes?
How much of the time do you spend in like an emulator versus on a physical device with AV or whatever?
Yeah, we focus on physical devices for several reasons, but one of them, some things don't work right in the emulator, whether you're using like Google APIs. Actually, I know they have Google API images now, but we use jailbroken or rooted devices for our testing. That includes special tools that we've developed in-house to do certain things that I was talking about to help our testers get through that. So we usually stay clear of the emulators just so we can use our own tools.
Where do I begin? I mean, if I now have the job of, hey, we have a mobile app, secure it. Okay, learning curve. Like, where
That's a great question. I would start with the network. I wouldn't worry about the physical device yet. I would worry more about the back end, right? Because that's where you're going to steal a lot of information if that's vulnerable. So I would start, like I was talking about, man in the middle. So use any proxy, basically, and configure your device to run through the proxy. You'll need to have them disable probably SSL cert pinning. I think Burp probably doesn't it have a way to disable cert pinning as well? I can't remember what that feature's called. But Burp can do it as well. And watch the traffic and see what's happening, and then that gives you your attack base for the back end, because now you see RESTful requests going over. Okay, now I can put that into Burp or WebInspect and start attacking and injecting those parameters in the API and looking for issues there. That's sort of the easy one. Working on the device and finding those is a bit more difficult because you do need usually rooted or jailbroken devices, start poking through directories. It's a much more manual process. There's also, everyone's familiar with WebGoat. There's Goat Droid, which is a purposely vulnerable mobile app that helps you test and learn how to test. So there's lessons on that as well. And that's a great, Goat Droid is great because it shows examples of all of these almost that I've shown.
Is there a recommended methodology or like a testing guide, kind of like the OS testing guide out there, but for mobile stuff?
I'm not aware of one. There is a mobile top 10, OWASP mobile top 10 vulnerability list, which focuses on just mobile, but that's not really a methodology for testing, right? But it's an idea of what maybe your top areas to look for. But I'm not familiar with a methodology guide that's sort of renowned, right, or like the official version. We have them internally, but I'm not aware of a public one.
OWASP has a mobile testing guide and a mobile ASVS. They're actually really good. So
there you go. Thank you.
You mentioned Burp Suite. Do you like, or does anybody have a preference of any other types of proxies? Like Z-Attack proxy, or there's one from
Charles Proxy.
Charles proxy?
Charles for iOS is pretty good.
Okay.
Yeah, we use not to toot our own horn, but web inspect in the sense that we can handle mobile backend testing. So basically what you do is you configure your device to proxy through web inspect. And so after you're done exercising the app, finding all, clicking my friends and this and that, and then in web inspect you just click audit. And it's already captured your entire threat surface of that mobile app, and it just goes to town on it. So that's what we use internally for the back-end testing. But as far as other ones, of course, you could use Burp or Charles Proxy, just about anything, but whatever you're comfortable with. And that can do SSL man in the middle if your development team doesn't give you one with it disabled. Questions on this side?
Are these slides available?
Are these slides going to be available? I can make it. Is that a BSides thing?
I believe there are going. I don't know. I don't know.
We'll have to find out. Hopefully, if I have no problem making them available. So hopefully we can do it through BSides.
You gotta follow them on Twitter and tweet them.
Yeah. Don't be embarrassed by tweeting. BB is best.
I got to create another account.
Right.
Burner account. Just flip through while I take pictures.
Well, that's all I got, guys. Thank you so much. And I love talking this stuff. So
Where are you based? Are you based here in Columbus?
I'm in Atlanta. So our dynamic testing team's in Atlanta. Our static testing teams are in California. So that's kind of how we're split up.